Hello students, in this session we are going to see about the application part of Gauss law. So far we have seen the electric field created by a point charges and how to calculate the electric field generated by a point charge and all we have discussed. Now we will move on to the application part of Gauss law. Just recall the Gauss law and its definition. So the first application of Gauss law is electric field due to a long charged wire. So suppose I'm considering this is a charged wire. This pencil is a charged wire means it will also generate an electric field around it. So how we can calculate this? By using Gauss law we can calculate this. In order to calculate field created by the long charged wire, I'm just considering one Gaussian surface. So Gauss, if you wanted to apply the Gauss law means you have to choose one Gaussian surface. Gaussian surface is nothing but the surface which you are taking for the application of Gauss law is called Gaussian surface. So I'm taking a cylindrical surface. So if suppose this is a long charged wire means it will generate an electric field around in a circular manner. So that is for the reason I'm taking the Gaussian surface as a cylindrical one. So if suppose from the center of the charged wire I'm going to measure the electric field at this point. If suppose taking any point on the Gaussian surface which will be the same in magnitude because all are radially outward. If suppose I'm taking any cylindrical path means all points on a surface will give you the same electric field around it. For that purpose I'm just taking cylindrical surface. Okay, this is what the structural diagrammatical representation is given. So this is what the long charged wire which I am considering. So I'm going to find electric field generated by this charged wire at a point P. So this is what this Gaussian surface that I am taking. So Gauss law only applicable for the case of closed surface. So I'm taking a closed surface. So this is what the point which I have taken P at a distance R. So electric field always pointed away from this direction. All the directions the points will be pointed out. So three surfaces. So if suppose you are considering a cylinder means here a closed cylinder means there are three different surfaces. One is here and another one is here and third one is a lateral surface. This is what the surface 1 I'm taking. The field area vector can be represented n dot ds for the case of surface 1 and this is for the surface 2 and lateral surface which is the third surface. So all the three surfaces we are going to find out the electric field created by this long charged wire. So consider a long charged infinite wire with a uniform linear charge density lambda. So why we are taking linear charge density? We have already seen three different kinds of charge densities. One is linear charge density, another one is volume charge density and surface charge density. This is along the length. For that purpose we are taking linear charge density as lambda. So according to Gauss law, electric flux phi that is equal to surface integral of E dot ds which is equal to Q by epsilon naught. This is as equation 1. So we have to consider three different surfaces. So all the three different surfaces will have a electric flux along the direction. Here the field direction is along radially outward as I have told. So the net flux phi which is equal to phi 1 plus phi 2 plus phi 3. Phi 1 corresponds to the surface 1 and phi 2 corresponds to the surface 2 and phi 3 corresponds to the surface 3 that we have taken. So by using this relation phi is equal to surface integral of E dot ds which is equal to for each surface we have to write. So for the surface 1 integral of E dot ds for surface 1 plus surface 2 also surface 3 and all we are writing the same. This is surface 3. So next step. So E dot ds means how we can write it. E dot ds means you can write E ds cos theta. This is already we have discussed in previous videos. So a dot b is equal to written as a dot b can be written as ab cos theta. Dot product of any two vector can be written in the form of ab cos theta. So from this I am writing E ds cos theta for each surfaces. This is for surface 1, surface 2, surface 3. So for surface 1 and 2, theta is 90 degree. How it is 90 degree means the field is in this direction, that is electric field generated by the length is in this direction. The area vector acts along this direction. So field direction will be like this and area vector along this direction. So the angle between them is 90 degree. Clear what I am coming to say is theta will be 90 degree means cos 90 will become 0. So substitute for surface 1 and 2, the cos theta value will be 90 degree. So for the surface 3, it is along the direction. The area vector and the theta value both are in the same direction. So for the surface 3, theta value will become 1. Cos 0 degree is 1. So then the above equation becomes, so substitute the theta values in this equation. When you substitute this, cos 90 will be 0. The entire expression will become 0 for the case of surface 1 and surface 2. For the surface 3, it is 1. When you substitute 1 is in the above equation, 5 will be equal to integral of E dot ds you will get. So integral of E dot ds means E is a constant. Take it outside. Integral of ds means integral of dx is what? X. So integral of ds will be yes. This is what the expression you get. So next is, this is the lateral surface area. So total surface area is different for the cylinder. So only the field is we are going to find along the lateral surface area. So the surface area can be substituted as lateral only. The lateral surface area of a cylinder is 2 pi RL. Instead of this surface, you can replace 2 pi RL. Take this as a equation 2. From equation 1, that is from Gauss law, the definition, phi is equal to Q by epsilon naught. So from this expression, we can replace it, the phi value. Phi value is E 2 pi RL, which is equal to Q by epsilon naught. So next further, what we have to do, charge enclosed by the wire. So if you are considering a length of wire, it can consist of so many number of charges. So the charge enclosed by this length can be found using the linear charge density formula. That is, linear charge density is lambda is equal to Q by L, or Q is equal to lambda by L. So when you replace all those values, E 2 pi RL, which is equal to lambda, from Q value you have to replace lambda into L by epsilon naught. L get cancel each other. E will be a lambda by 2 pi epsilon naught into R. So in the vector form, you have to multiply one unit vector along this only. It can be represented in the form of vector only by adding unit vector. So there are three conclusions. If lambda is positive, E will also be positive and directed outwards. That means if it is positive, it will be towards outward direction. So lambda is negative means it is opposite, inward. So previously charge, we have mentioned it by charges. Plus Q charge means radially outward, minus Q charge means radially inward, we have seen. So here lambda is positive means field is outward. Lambda is negative means field is inward. Next is field is inversely proportional to the distance r. If the point is so far from the length of wire means the field will be minimum. If it is closer to the length of wire means it is maximum. That is what the final statement given here. Thank you.